Rules for the nth term in a sequence, modelling geometric growth and decay. So now this is working out the nth term in a sequence for growth and decay. So we'll do both. So while we can generate as many terms as we like in a sequence using a recurrence relation for geometric growth and decay, it is possible to derive a rule. So we did this for linear before, so now we're going to do this for this one. But the best way to do this is by looking at an example.
Okay, so we have an initial amount of $2,000 and we have to work out what's going to be in there after 1 year once the compound interest has been added. So effectively we're multiplying it by capital R. So we're saying 2,000 times 1.05 in this case. To get our next term, by pressing enter, we're effectively saying 2,000 times 1.05 times another 1.05, which is the same as saying 1.05 squared. Each time we press enter, what we're asking the calculator to do is continue to multiply it by 1.05. So that's where those powers come into play.
And so on and so forth to generate those numbers. So following this pattern, after n years interest has been added, we can write this as our formula. So this is the rule that we can now predict it for 20 years, 30 years, 100 years, whatever. So
if it was 20 years, we'd say V20 is the term that we want. So it's 1.05 to the power of 20, because we want that to times itself 20 times, times what we started which was $2,000.
So in 20 years, the 2,000 will grow to 5,306.
Okay, so if we wanted to work out how much interest it had made in that time, we would have to take 2,000 away from that $5,306.60. So it's really important to see what the question is asking. If it's asking us to find out how much is in there after 20 years, well, it's $5,306.60. If we just were asked to calculate the interest, we'd have to take out what we put in there first.
So that is the rule. You've seen this before anyway, but just there for you to have a look at, and let's have a look at some examples to work with. But before we do that, let's just look at this again. Compound interest on loans and investments. So if I'm talking about compound interest, you've seen this formula before. And if it was reduced balance, you've seen this formula before. What's changed again? That's there. It's just extra for your notes. So
one is growth and the other one is decay.
So that one would be growth and that one would be decay. And we'll move on to some questions for each one. Right. The principal value of 10,000 is invested, so that's growth, earning compound interest at the rate of 9% per year. The rule for the value of the investment after n years, so they've given us the rule. There it is there. So now it just says find the value of the investment after 4 years, find the value of interest earned after 4 years. So again, interest earned they want for that one. So that's just a matter of dumping it into the calculator, getting your answer, and then subtracting it from the original principal amount. Very easy. And C says find the amount of interest earned in the 4th year. This is important, guys, in the 4th year. We'll do this, right? And then the next one says if interest compounds monthly instead of yearly, write down a rule for that. So we've got to change something here. And then the next part, after 4 years, which is 48 months for investment, find out the value of the investment. So let's look at doing the first one. It said after 4 years, what's the value of the investment? You would just type in 1.09 to the power of 4 times 10,000. That gives us that. So after 4 years, again, it's in English, sentence. After 4 years, the value of the investment is that, correct to the nearest cent. Then the next question asks for the amount of interest. Mm-hmm. Then what was it grew to that. We invested that. So it's just that minus that, which gives us $4,115.82. And then again, you have to write it out. After 4 years, the amount of interest earned is $4,115.82.
Now, the amount of interest earned in the 4th year is equal to 9% of the value of the loan after 3 years. Okay, so what does that mean? We have to look at how much has it grown between that period of time. So we have to find V3 first and say, in this case, 1.09 to the power of 3 times 10,000, and that gives us an amount. Once we've looked at that amount is $12,950.29, and we need 9% of that, because that's going to give us the percentage, that's going to tell us how much interest it's earned between the third year and the fourth year.
So you just do 9 divided by 100 times 12,950.29, and that'll give you that amount. So interest of $1,165.53 was earned in the fourth year.
So between the third year and the fourth year.
So then it said in that original question, I'll go back to it so you can see it. If the interest compounds monthly instead of yearly, write down a rule for the value of the investment after n months. So now we're changing. It was 9% per year, correct? So there's 12 months in a year. You divide that by 12 and you get 0.75% for a monthly interest rate. So there's your capital R. R equals 1 plus, we did 1 plus 9 divided by 100 before. So for monthly, it would be 1 plus 0.75 divided by 100, giving us this amount. And then you've got the new rule. So nothing else changes except for that is now in months. And then they said work it out after 48 months. So we've got to find V of 48 using the monthly rule, which is this one. And then you would just do 1.0075 to the power of 48 times your 10,000. And I'm going on an angle because I'm running out of screen space. And then you'll get this as your amount. Another one. This one now is on reducing balance depreciation. Again, reducing balance means it's going down. It's decreasing. So let's have a look at this example here. A computer system costs $9,500 to buy. Massive computer system. And it decreases in value with reducing balance depreciation of 20% each year. So that means reducing balance depreciation 20% every year of what it's worth at the end of that year. Not on the original amount. That's simple. That's flat rate depreciation. So now we're doing reduced balance. So a recurrence relation that can be used to model this value, so they've given it to us. Here is the recurrence. Well, you can work that out anyway.
So the 0.8 has come from saying finding capital R. That's what 0.8 represents. But that's come from 1 minus R over 100 because it's decreasing.
So 1 minus 20 on 100, which gives us 0.8. So that's where that comes from. So it says, write down the rule for the value of the computer system after n years. Use the rule to find the value of the computer system after 8 years. What's it worth to the nearest cent? Don't forget that. And then calculate the total depreciation of the computer system after 8 years. So, again, initial value, we've already done this, and we know that that is our sequence. Then we're going to find out V of 8, our rule, sorry. V of 8, 0.8 to the power of 8 times 9,500. There it is there. $1,593.83.
So a computer system that started off being worth $9,500 after 8 years is now worth $1,593.84, correct, to the nearest cent. So please be very, very mindful of that. Question C asked us to find the total depreciation. So we have to find the difference between what it was worth, what it is worth now after 8 years. So it's actually dropped in value or depreciated by $7,906.16.
Moral of the story, don't buy a computer system worth $9,500. Another example. How many years will it take an investment of $2,000? So we're giving money to the bank, so it's got to grow, paying compound interest of 6% per annum to grow above $3,000. Write your answer correct to the nearest year. So our initial investment is $2,000. Our interest rate is compound, so big R, is 1 plus 6 on 100, so we get this. And, oops, my fault, go back up. So my initial investment was that, and they're saying that they want it to grow to 3,000, and we want to work out how much does it grow to 3,000. So what am I potentially trying to find? I'm trying to find the value of n. That's what I don't know yet. So all you have to do, you can use solver on the calculator, that 3,000 equals 1.06 to the n times 2,000, comma, that should be comma n, enter, and it'll give you this. Now guys, is this yearly, monthly, what is it? Because we had this here before as per annum, we get 6.9, so this is all years. It will take you, we've got to do it to the nearest year, it'll take you 7 years for that to grow.
To get to 3,000 or past 3,000.
Another one?
One more.
Okay. An industrial weaving company purchased a new loom. What's a loom, miss? I've got no idea. Something to do with textiles, I think. Costs, it's probably a machine, costs $56,000, an expensive loom. It has an estimated value of $15,000 after 10 years of operation. Looks like unit cost, doesn't it, almost? If the value of the loom is depreciated using reduced balance method, so when you see reduced balance method, write the formula down, and then you'll know what to do. And it just says, what is the annual rate of depreciation? What am I trying to find here? I'm trying to find R, because they were not big R, they want to find little r, because we need a percentage here. So then you write down your...
you write down everything you know.
So we know that the initial value was that.
What you don't know.
VN is going to be worth 15,000 after so many years, which we don't know. So that's R. Sorry, the interest rate we don't know. No. It says in here it's after 10 years, doesn't it?
Yep.
So we know that N is equal to 10 as well. We know that what big R is, so we know that. And now it's just substituting. But you guys don't need to do this by hand. You just use your solver and that will give you the answer. So what we're trying to do here is we're trying to solve this once you've plugged it into the formula. And then you put that into the calculator like this. Solve 15,000 minus open bracket 1 minus little r on 100, all to the power of 10 times 56,000. That was the principal amount. Comma r, enter, and you're going to get r is equal to 12.34 and 8F.
8F. So have a go at all of the questions in exercise 8F, and if you have any questions, we'll go through them as required.